Mesothelioma is a rare type of cancer that develops from the mesothelium, which is a protective lining that covers most of the body's internal organs, such as the lungs, heart, stomach, intestines, and reproductive organs. The most common type of mesothelioma is pleural mesothelioma, which begins in the lining of the lungs, the pleura. Mesothelioma is considered an aggressive cancer and it is typically quite advanced by the time signs and symptoms appear. It can take many years, even decades after exposure to asbestos for mesothelioma to develop. Asbestos exposure is the main risk factor for mesothelioma because asbestos fibers easily become lodged in the lining of organs and cause inflammation and mutations that can lead to cancer over time. Because of the long latency period between asbestos exposure and diagnosis of mesothelioma, most patients are not diagnosed until the disease is in an advanced stage. Earlier detection would improve treatment options and outcomes for patients. One method being explored for earlier detection of mesothelioma is the analysis of volatile organic compounds, VOCs, in a patient's breath. VOCs are gases produced by biochemical processes in the human body and they can be indicators of cancerous changes at the cellular level. Different types and concentrations of VOCs are found in a person's breath depending on their health status. Researchers believe certain VOC biomarker signatures may emerge in the breath of mesothelioma patients that could help detect the disease earlier before radiological changes or symptoms manifest. Several studies have shown promising results for identifying mesothelioma through breath analysis. In a 2010 study published in the journal Cancer, researchers analyzed breath samples from 76 patients with confirmed mesothelioma diagnoses and 51 healthy controls using gas chromatography-mass spectrometry (GCMS). The GCMS analysis identified 20 VOCs that were elevated or depleted in the breath of mesothelioma patients compared to controls. When these 20 VOCs were used to develop a diagnostic model, it was able to correctly classify the breath samples of mesothelioma patients versus healthy controls with 79 to 85% accuracy. Another notable study published in 2013 in the International Journal of Cancer analyzed breath samples from 98 patients with mesothelioma and 176 healthy controls using a technique called ion mobility spectrometry. The study found 13 VOCs that were significantly different between the two groups. A diagnostic algorithm based on these VOCs was able to detect mesothelioma in breath samples with a sensitivity of 83% and specificity of 76%. More recent research continues to improve the ability of breath analysis to detect mesothelioma. A 2021 study published in Scientific Reports collected exhaled breath condensate samples from 43 mesothelioma patients and 22 healthy volunteers for analysis with proton nuclear magnetic resonance, 1H NMR, spectroscopy. This method identified 20 metabolites that differentiated mesothelioma patient samples from controls. Using a partial least squares discriminant analysis model based on these metabolites, mesothelioma could be detected non-invasively in breath samples with 95.3% sensitivity and 81.8% specificity. While further research is still needed, these studies provide strong evidence that breath analysis has real potential to aid early detection of mesothelioma. Compared to conventional screening methods like chest imaging and biopsies, breath tests are non-invasive, inexpensive, and could enable more frequent screening. Breath tests may also one day have utility as a liquid biopsy by helping monitor treatment response and early detection of recurrence or progression in patients already diagnosed with mesothelioma. Breath analysis is not yet at a point where it could replace standard diagnostics. More validation studies with larger cohorts are still needed before breath tests for mesothelioma could be transitioned to clinical use. Researchers are also working to standardize breath collection and analysis methods to facilitate multi-site clinical trials. Overall, breath analysis shows promise as a tool that could help transform mesothelioma screening by enabling earlier detection of this aggressive cancer through non-invasive means. As the technology advances, breath tests may become part of an improved strategy to screen high-risk asbestos-exposed individuals. Combining breath biomarkers with imaging and serological tests could maximize diagnostic sensitivity and specificity for detecting mesothelioma at its earliest possible stages. While mesothelioma remains quite difficult to detect earlier through conventional means due to its long latency period and non-specific early symptoms, preliminary research on the analysis of inhaled breath indicates this methodology holds strong promise for aiding earlier detection through a non-invasive approach. Several proof-of-concept studies have successfully identified breath biomarker signatures that differentiate mesothelioma patients from healthy individuals. As the standardization of breath collection and analysis methods continues along with larger validation studies, breath testing shows potential to one day enhance mesothelioma screening strategies and enable improved treatment outcomes by facilitating earlier diagnosis when the disease is still localized. However, breath analysis is not yet at the point of replacing standard diagnostic modalities and requires further refinement before being transitioned into clinical use. But with advancing technologies, breath tests may eventually help address the challenge of late-stage detection that is characteristic of mesothelioma.